Audio Jungle.
Walang makahahadlang, walang maiiwan. Sama-samang lilipad, kamtin ang pangarap. Sa hamong kinakaharap, patuloy na aangat. Edukasyon para sa lahat, sulong edukalidad. Ito ang Masinlok School on the Air at mapakikinggan sa Serbisyong Putog Radio, DWSP 101.5 News FM.
Good day, Masinlok, Zambales.
Good day to our dear grade 9 learners. You're listening to Masinlok School on the Air, Serbian Putog Radio, DWSP 101.5 News FM. I am Mary Christine C. Ignacio
And Reynalyn Ravana Hidalgo from Bamban National High School.
at your service. We would like to acknowledge our Department of Education writer, Ma'am Rona I. Monsayak.
Get ready, learners. Prepare your notebook and pen so that you can take down all the important details in our lesson. Find a comfortable place where you can listen and study properly.
Welcome to our new mathematics adventure. We are now on the 8th week of the third quarter for this school year 2020-2021.
Today's lesson is all about applying the theorems to show that given triangles are similar and proving the Pythagorean Theorem. At the end of the lesson, you are expected to apply these theorems to show that given triangles are similar and prove Pythagorean Theorem.
But before we proceed to our topic, let's see if you could still remember our previous lesson. Number 1. Two triangles are similar if two angles of one triangle are congruent to two angles of another triangle. What theorem is it? Very good. That's AA or angle-angle similarity theorem.
If the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. What theorem is it? Correct! It is the right triangle similarity theorem.
Number 3. It is a theorem which states that two triangles are similar if two corresponding sides of two right triangles are in proportion. Excellent! That's definitely SSS or side-side-side similarity theorem.
Number 4. What theorem states that triangles are similar if an angle of one triangle is congruent to an angle of the other triangle and the corresponding sides are in proportion? That's right! It's SAS or side-angle-side similarity theorem.
Number 5. What theorem has two special right triangles, namely 45-45-90 degree triangle and 30-60-90 degree triangle? Correct! That's special right triangle theorem. Wow, I am very impressed. You have a very good memory. Now let's begin our mathematics adventure.
Level 1. Which picture shows similar triangles? Is it picture 1 with triangular boat plugs? Or is it picture 2 with a hot air balloon? Correct! It's the first picture. Now, let's take a closer look at the picture. As we can see, an angle in the first triangle is congruent to an angle in the second triangle, and the corresponding sides are proportional. Therefore, we can prove that these triangles are similar through the SAS similarity theorem. Now, let's try to solve a problem using the concept of SAS similarity theorem. Find the length of the unknown. First thing we have to do is to identify the corresponding sides. 4 corresponds to 16 and 7 corresponds to x. Let's write it as 4 by 16 is equal to 7 by x. Then, we'll apply the fundamental rule of proportion. We multiply 4 by x, which is 4x, and 7 times 16 equals 112. Then, we now have 4x equals 112. To simplify the equation, we're going to divide both sides by 4. 4x divided by 4 is x, and 112 divided by 4 is 28. Therefore, x equals 28.
Level 2. Which picture shows similar triangles? Is it the triangular signage in the first picture or the dog's playground in the second picture? Great job! The signage shows similar triangles. If we are going to analyze the figure, there are 2 triangles. The first triangle is the red outline of the signage, and the second triangle is the white triangle inside. We can prove that these triangles are similar through SSS similarity theorem because all of the corresponding sides are proportional. Next, let's explore problems under SSS similarity theorem. Find the length of the unknown. In this case, we should also use the proportionality of the corresponding sides to find the value of the unknown. 36 corresponds to 12, 24 corresponds to 8, and 30 corresponds to B. We have 2 options to solve the problem. Option number 1. 36 over 12 is equal to 30 over B. Or option number 2. 24 over 8 is equal to 30 over B. Let's use option number 1. First, 36 over 12 is equal to 30 over B. Now let's multiply 36 by B and 30 by 12. We will have 36B is equal to 360. Then we divide both sides by 36. 36b divided by 36 is equal to b. And 360 divided by 36 is equal to 10. Therefore, the value of b is equal to 10. How about if we use the second option? Could we have the same answer? Let's see. 24 over 8 is equal to 30 over b. Now, let's multiply 24 by b and 30 by 8. Then, we will have 24b is equal to 240. Next, we divide both sides by 24. We will have b is equal to 10. We can use either of the 2 equations because the result will be the same.
Level 3. Which among the pictures show similar triangles? Is it the curved road from the first picture or the bridge from the second picture? Excellent! The bridge shows similar triangles. As we can see, there are two triangles formed in the bridge and the corresponding two angles of the triangles are congruent. Therefore, we can prove that these triangles are similar using the AA or angle-angle similarity theorem. Let's find the measure of angle C and angle B using the AA similarity theorem. First thing we have to do is to analyze the given measurements. In here, we have measure of angle D equals 90 degrees and measure of angle E equals 50 degrees. Both given can be found on triangle DCE. Therefore, we can easily solve for the measure of angle C. Measure of triangle DCE is equal to 180 degrees. Measure of angle D plus measure of angle C plus measure of angle E equals 180 degrees. Let's substitute the given data to solve for angle C. Then, we will have 90 degrees plus measure of angle C plus 50 degrees equals 180 degrees. Now, let's combine similar terms. 90 plus 50 equals 140. Then, we'll have measure of angle C plus 140 degrees equals 180 degrees. Lastly, using the addition property of equality, we will have measure of angle C equals 40 degrees. How about the measure of angle B? Well, that's right. Measure of angle B equals measure of angle E because B corresponds to E and corresponding angles are congruent. Therefore, measure of angle B is also equal to 50 degrees.
Level 4. Which picture shows similar triangles? Is it the first picture, which is a right triangle cut by an altitude to the hypotenuse, or the combination of an acute triangle and right triangle on the second picture? You're definitely right. The first picture shows right triangle similarity theorem that states that any triangle with an altitude to the hypotenuse forms two triangles similar to each other and to the original triangle. Assume that line segment CD is the altitude to the hypotenuse of AB of right triangle ACB. Find CD if AD is 3 and BD is 12. In order to solve this, we have to remember the corresponding parts of the triangle. Let's make the illustration simpler. AD from the first triangle corresponds to CD from the second triangle, and CD from the first triangle corresponds to BD from the second triangle. Then we substitute the given values. 3 over CD is equal to CD over 12. Multiply 3 by 12, we will have 36, and CD times CD is equals to CD squared. In order to simplify the equation, let's get the square root of both sides. Square root of 36 is 6, and square root of CD squared is CD. Therefore, line segment CD is equals to 6.
Aside from that, there are two kinds of special right triangle theorem. First, the 45-45-90 triangle, and the second one is the 30-60-90 triangle. Let's take 45-45-90 triangle first. Triangle PRS is 45-45-90 triangle. If line segment RS equals 16, then find its corresponding line segment PS. In order to solve this kind of problem, we have to remember the formula in 45-45-90 triangle. First formula is for finding the value of the hypotenuse. hypotenuse is the longest side and it is the opposite side of the 90-degree angle. Hypotenuse equals leg times square root of 2. The two other sides are called the legs. These sides have the same value, and in finding the value of the legs, we will use the formula leg equals hypotenuse times square root of 2 divided by 2. Now, let's answer the problem. Line segment PS happens to be the hypotenuse of the triangle. So, we will use the formula hypotenuse equals leg times square root of 2. Then, let's substitute the given. Therefore, the measurement of line segment PS or hypotenuse equals 16 times square root of 2.
Now let's use 30, 60, 90-degree triangle. The length of the hypotenuse of a 30, 60, and 90-degree triangle is 16. Find the length of the shorter leg and the longer leg. First, let's identify the parts of this triangle. Number 1, the hypotenuse. It is the longest side and the opposite side of 90 degrees. Number 2, the longer leg. It is the opposite side of 60-degree angle. Number 3, the shorter leg. It is the opposite side of 30-degree angle. Now let's use the following formulas. Hypotenuse is equal to 2 times the value of shorter leg. Longer leg is equal to the value of shorter leg times square root of 3. And shorter leg is equal to hypotenuse over 2. In this problem, we have to use the formula for shorter leg and longer leg. Our hypotenuse is 16, and if we divide it by 2, it will become 8, and 8 will be the value of our shorter leg. While for our longer leg is equal to shorter leg times square root of 3. Then, we will have longer leg, or B, is equal to 8 square root of 3.
Level 5. What is Pythagorean Theorem? The Pythagorean Theorem is attributed to the Greek mathematicians and philosopher Pythagoras, and his followers who proved this theorem about 2,500 years ago. The square of the hypotenuse of a right triangle is equal to the sum of the squares of the legs. The formula for Pythagorean theorem is the well-known c squared equals a squared plus b squared, where c is the hypotenuse, while a and b are the legs. There are other formulas that we can derive from the original formula. Using the formula transformation, we have a squared equals c squared minus b squared, and b squared equals c squared minus a squared.
Let's find the length of C. If A is equals to 3 cm and B is equals to 4 cm, we can solve this using the Pythagorean theorem, or also known as Pythagorean triples. We will use the formula c squared is equal to a squared plus b squared. Then, let's substitute the given. C squared is equal to 3 squared plus 4 squared. Now, let's simplify. 3 squared is equals to 9. 4 squared is equals to 16. 9 plus 16 is equal to 25. In order to get the value of c, we should get the square root of c squared and 25. The square root of c squared is c, and the square root of 25 is 5. Therefore, the value of c, or the hypotenuse, is 5 centimeters.
What if the value of the leg is the unknown? Let's take this problem. Find the length of the leg A if b equals 3 centimeters, and c equals 4 centimeters. In order for us to solve this, let's have a formula transformation. Instead of c squared equals a squared plus b squared, we will use a squared equals c squared minus b squared. Now, substitute the given values. C equals 4 and b equals 3. Then, we will have a squared equals 4 squared minus 3 squared. Let's simplify. 4 squared equals 16 and 3 squared equals 9. Next, 16 minus 9 equals 7. Then, we now have a squared equals 7. To simplify the equation, we need to get the square root of a and 7. The square root of a squared is a, and 7 is not a perfect square, so it will remain square root of 7. So the answer is a equals square root of 7 centimeters.
Now let's try this worded problem. How high up the building can a 10-meter ladder go if its foot is placed 6 meters away from it? First, let's analyze and identify the given in the problem. C is equals to 10 meters, which is the length of the ladder. And A is equals to 6 meters, which is the distance between the ladder and the wall. In order for us to solve this problem, we will use b squared is equal to c squared minus a squared. Then, we will have b squared is equals to 10 squared minus 6 squared. 10 squared is equals to 100, and 6 squared is equals to 36. Then, we subtract 36 from 100, which is equal to 64. b squared is equals to 64. To simplify, let's get the square root of b squared and 64. Then, the answer is b is equals to 8 meters.
Our last task is proving Pythagorean Theorem. In proving, we have to analyze the details of the triangles in the different theorems and postulate that we need to validate in our statements. Let's try to prove this one using the following given. Line segment LM equals R and line segment MN equals S as the legs. Line segment LN equals T as the hypotenuse. Triangle LMN is a right triangle. Prove R squared plus S squared equals T squared, or T squared equals R squared plus S squared. First thing that we need to do is to separate the triangles in order for us to fully visualize and identify the corresponding parts of the triangle. Now we have triangle LMN, triangle MKN, and triangle LKM, and these triangles are similar according to the right triangle similarity theorem. Next, let's now identify the corresponding parts of the triangle. U by R equals R by T, and B by S equals S by T. It is according to special properties of right triangles. After that, we should use the fundamental rule of proportion in order to simplify the equation. U by R equals R by T will become R squared equals U times T, and V divided by S equals S by T is equal to S squared equals V times T. Next, we should combine the two equations according to the addition property of equality. R squared equals U times T plus S squared equals V times T will become R squared plus S squared equals U times T plus V times T. Then, using the common monomial factor, we will now have R squared plus S squared equals T times the quantity U plus V. Lastly, according to the segment addition postulate, the quantity U plus V is equal to T. And we will have r squared plus s squared equals t squared.
And that's the end of our mathematics adventure for today. Congratulations, dear learners! You are now ready to answer the fun and exciting activities in our module.
Always remember, if two triangles are similar, their corresponding angles will be congruent, and their sides will be proportional. You can use the fact that their corresponding sides are proportional and their corresponding angles are congruent to solve problems once you've proven that the two triangles are similar.
Pythagorean Theorem is only applied to right triangles. It is used to find how long an unknown side based on the length of the two other sides. Pythagorean Theorem states that in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the length of the legs.
That's all about applying the theorems to show that given triangles are similar and proving Pythagorean Theorem.
To our dear parents and guardians, thank you for your support and help to our beloved learners. We are open for your questions regarding our lessons. Just send a message to us through your cell phone numbers and class group chat. Once again, I am Mary Christine C. Ignacio.
And I am Rinalyn Ravana Hidalgo, your honorary teachers from Bamban National High School.
Thank you and God bless.